तो बच्चों इस वीडियो में हम लोग ये प्रॉब्लम सॉल्व करेंगे फॉर OF2 molecule consider the following. So they have given some statements about OF2 molecule. We have to find which ones are correct. The first one is number of lone pairs on oxygen is 2. So let us find out how many pairs are there, lone pairs are there on the oxygen. So if you draw the Lewis-dot structure for this molecule, this is how it is going to look like. Oxygen is 6 valence electrons, out of which 2 will be used to make the bonds with the fluorine, and remaining 4 will stay on as the lone pairs. So there are 2 lone pairs. That means option A is correct. Okay, option A is correct. Next one is FOF angle is less than 104.5 degree. So this angle is 104.5 degree less than that. So that one is also correct, B. And reason why this is less than 104.5 degrees because there is this lone pairs on the oxygen, and also you can see that on the fluorine as well there is these lone pairs, 3 lone pairs, and that's why these bonds are pushed further, and that's the reason this angle is less than 104.5 degree. The next oxidation state of oxygen is -2. So this oxygen is there at the center, right? Oxidation state of this is -2, it is saying. So oxidation state is basically calculated as how many electrons it has lost, basically. Okay. So if you look here, oxygen has 6 valence electrons, and out of that it has lost 2 electrons. So the oxidation state of the oxygen in this molecule is +2. Okay, and not the -2. And the reason why it has lost 2 electrons, even though there is a bond between oxygen and fluorine, since fluorine is more electronegative, that electron in the bond will be pulled towards fluorine. Okay, and that means oxygen is going to lose 2 electrons from these 2 bonds. So it has lost plus like 2 electrons, and that's why oxidation state is +2. So option C is incorrect. Next one is molecule is bent V-shaped. So you can clearly see that this molecule is bent V-shaped because of the lone pairs, 2 lone pairs on the oxygen atom, and that's why it is bent V-shaped. So option D is also correct. Then finally, molecular geometry is linear. This is also incorrect. The reason being, there is this lone pairs on the oxygen central atom, which pushes these bonds, and the angle is made, and that's why it cannot be a linear. So A, B, D, these are the correct options. That's why fourth option is correct. You can also eliminate some of the options. So if you consider here C, D, E, the first option, we know that C is incorrect. That's why this option is terminated. Then B, E, and A. So we know that E is incorrect. So option 2 is also gone. Finally, we have got A, C, and D. So we know that C is incorrect. That's why this option is also gone. So only the remaining option is A, B, D. So that's how you can work around with these problems. So if you are not sure about some of the statements, for example, in this case, let us say you are not sure about this angle is less than 104.5 degree, for example. So you can start eliminating the options, okay? Because you are 100% sure that the number of lone pairs on the oxygen is 2. So the option A and option D are correct. So 1 and 2 option will be cancelled out anyway. So you have to select between these two, ACD and ABD. And from this, you also know that this option C is incorrect. Okay, oxidation state. This is very simple to find out using the electronegativity rule. And so only the option that remains is the fourth option. Thanks for watching.